Thank you very much. I love it how it tells me that. I used to feel like when I was teaching an online class, the reason why it tells you that is because nobody would say a goddamn word in the online class. So that was the only time anybody was going to talk to me. No, it was like fight. It was like a fight to get people to talk sometimes in the online class. It's crazy. Because they have online live. Do you know what I'm talking about? No. Zoom, yeah. But like you do like, oh yeah, whatever, Team Zoom, whatever. But the thing is like you do online live and like nobody really has to turn their camera on. Yeah, and then like half the time nobody is paying attention because like especially if the class is 3 hours long, you know what I mean? So it's usually it's like me and like one kid who's sitting there and talking or a woman who's like older usually. And then the it's just funny. You're like I'm like talking, I'm like, does anybody understand what I'm saying? Is anybody still here? Echo, like no, it's not people's fault, honestly. It's just not an easy way to do things. And then a lot of times people are choosing to watch the recordings later, which of course is fine, But then I'm sitting there and just like talking to nobody for like 3 hours, trying to guess what somebody would ask. All right, allow, sit lolly, Rachel. I'm missing some folks today. Melanie, Christina, Joel, Merciful, Cheval, Tanya, Franklin, Lucas, Matthew, I think it was St. Kavia. But Jaden, Annalise, Zane, Indira, Kamani, Chloe. All right. By the way, this attendance has almost no bearing on anything. I hate to say it, but it's true. What do we got to do today? I say let's finish this chapter today. When is your test scheduled for? Do you know? Really, the test scheduled. Well, you don't know. You don't read the syllabus. It doesn't say it. It should say it on this. I have to fix that then. If it doesn't say on the syllabus, it says it right here. So it needs to be done by the 20th. Okay. So yeah, we got to finish now. So what is this? 1, 2, 3. That's right. Yep, this is good. Okay. All right. So where were we here? This one. All right. Approximately what percentage of the people aged between 25 and 40 had a systolic blood pressure reading between 110 and 119? Well, this looks like 15%. And this looks like 35%. So I would say 50%. Add them together. Does that make sense? Don't forget also, all of these things are going to be recorded. All you have to do is click on Zoom that's online. Okay. Read the graph.
No, I see the 15%, but would you be right?
Read this. What's the height of the graph? Yeah, that's the whole thing. All right, question. By the way, I strongly recommend not taking pictures because it's a very bad way to study. Like very, very, very bad. Virtually nobody looks at the pictures. And then on top of that, it's very hard to read the pictures and understand what they actually mean when you're going back to them. So that's the whole point of me putting the video online. It's much simpler. Just watch that part again. You know what I mean? And then you have the picture because this screen is going to be on the video. Does that make sense? All right. Of course you can take pictures. I don't care, but I'm just telling you, it doesn't make sense, honestly. All right. So blood pressure readings, identify the center of the third class. All right, I want you to try to do this one. How do you find the center or class mark or class midpoint? No. Okay, so what would you do in this case? Well, you said something pretty close. Wait, which one's the third class? Which one's the third class? What's the height of the third class? 25% is correct. This is the third class here. Is that right? So how do we determine class midpoint, class center, class mark, any of that stuff? We talked about this last time, definitely. It was definitely on your homework also. How do you do class midpoint? No, come on. None of you remember? I went over a whole thing about midpoint. How do you find midpoint? You find the average of the biggest and the lowest, right? No. Does that make any sense? So like this thing here, it says the blood pressure readings were given to the nearest whole number. Identify the center of the third class. The center of the third class does not have anything to do with the percentages. This is a class here, right? We were trying to find a representative number for that class. Is that correct? So it should be something like 125. 125 is wrong also though. Close. But this one's actually a little hard. This one question here for this part. 125 is the only thing I can be answering. That kind of makes sense though. Saying something about these percentages makes no sense. You understand? Okay, because remember, we were always talking about there's a value and there's a frequency. We have to be able to answer which one for the appropriate question. Does that make sense? All right, so frequencies are not answering this question. Does that make sense? It doesn't tell me anything. It tells me how many things are happening in the third class. It doesn't tell me about, like the size of like what the third class really means. Does that make sense? So then this thing here, you're very close though. Okay, so the 120 and 130 plus 2, or excuse me, add those two things together and divide by 2 to find the midpoint. Yeah, very close. But can I put 130 in this class? No, because the thing is like if this class starts at 100, right, and this class starts at 110, then that means 110 is not in this class. 110 is in this class. Is that correct? So 120 is in this class. So what's the biggest number in the third class? Because they say, now this is why this question is a little tricky. Because they say something about whole numbers here. Does everybody see that? Right? Then this class would really only go up to 129. Is that right? But that's a little easy to make a mistake. Okay. So then we would end up like that. I could understand you telling me 125. Okay. But now I think you see why it has to be 129 in this case. Does that make sense? Question? Anybody have any question here? So the reason why I find this hard is because this to the nearest whole number, like that's person might miss that. Does that make sense? If that means they're only getting blood pressure readings 120, 121, 122, 123, 124, 125, 126, 127, 128, 129, 130, but then 130 can't go in this class. Does that make sense? All right. This thing here is the shape of something that they want you to understand that we have to talk about a lot throughout this course. So this is called this general shape here is something that we refer to as a normal distribution. Or we say that this is approximately. Let's say this is approximately distributed normally. And then this is, of course, the shape of what we would say a normal distribution. This graph. Okay. So what does this mean? It means that you have like high frequencies here, then you have low frequencies here and low frequencies here. This thing is also like symmetric about some center. Does that make sense? Does that make sense? So then we started asking questions like what things. So why do they mention things about a normal distribution? Like normal distribution, the reason why we talk about it is a lot of different situations, things end up following this type of shape in terms of their distribution. Okay. So then the question I have is like, what random variables would have a distribution with this type of shape for their frequencies? Does that make sense? Does that make sense? So then if you have, does anybody have an answer? Anybody have a guess of what anything would like if I went and I started randomly picking something from somewhere, right? And I started looking at some numerical thing about it. What type of system would have something where you'd have like a lot of things that would happen kind of in the middle? Not so much for the high numbers, not so much for the low numbers. I wouldn't say average heights. Well, I guess you could say average heights, but I wouldn't say average heights. I would just say heights. Okay. So like if I said heights of people, now I'm drawing it a little bit weirder looking. That's not a very good drawing, to be honest. But the thing is let's try to make it. Like, I don't know. Let's say that the average height of a woman is 5'4". I'm just making this up. Let's just pretend. Okay. Then if we add let's say there's something that we're going to talk about today called the standard deviation. So let's say the standard deviation is about 2 inches. So let's say I add 2 inches. I get 5'6". And what is this? 5'2". Let's say I add another 2 inches. I get 5'8" and 5 feet tall. A normal distribution has a shape such that we'll talk a little bit more about this, but about 68% of the data ends up falling, we say, within one standard deviation. We have to explain what a standard deviation is, though. And then 95% of the data, if the data ends up being normally distributed, falls within 2 standard deviations. Again, we'll rewrite this completely, all right, when we get back to this. And then 99.7, it turns out, percent of the entire data will fall within 3 standard deviations. Okay, so it starts getting smaller very quickly. Does that make sense what I'm saying? Like there's not very much stuff on the outside here. Does everybody understand? All right. Now, it turns out that women's heights actually follow this type of distribution fairly well. There's a bunch of women that end up having heights somewhere around the average. Does that make sense? Then there's some really tall women, but they don't occur that often. Same thing with men's heights also. Then there's some really shorter people, and they don't occur that often. Does that make sense? Question? All right. A lot of things follow these types of distributions. Okay. There's a theorem that we're going to talk about later on called the central limit theorem. The central limit theorem is really the only reason why we have this class. But the central limit theorem states that effectively, when you start doing averages of things under certain conditions, the average is going to start following a normal distribution. So the reason why people call it a normal distribution is because it occurs so often. Start talking about averages, they start following this type of thing. And then there's all these different types of things that we can make conclusions about based off of it. Okay, so we'll talk about that. All right, the highway speeds of 100 cars summarized in frequency distributed below. Find T, the mean speed. All right, we're going to do this twice. One time I'm going to do this by hand, because otherwise I don't think you know what this means, and you don't think you're going to understand. And then the second time I'm going to do this by La Calculadora. Now, I want you to do it on the calculator, but you're not going to be able to answer the questions unless you understand what this is actually doing. And this is an extremely important concept in this course. All right. So we're going to talk about how to calculate the mean of some sort of distribution. Okay. What does mean again? So what is that? What's the formula? Correct. All right. Now, I want somebody to tell me what I'm adding up. How many numbers do I have to add up, and what are they? All right. We are consistently making the same error, but it's okay because I kind of set you up for this one. All right. Everybody always says that. Okay. Always. All right. But I need you to understand that there is a big difference between the value and the frequency. Does that make sense? Some questions are going to discuss things about the frequency, right? And some questions are going to be discussing things about the value. Is that correct? But you cannot just start taking any old numbers and then using those numbers to start answering your question. You must make sure you're answering the question that they're asking about. Okay. So these numbers here, what do they mean again? Those are frequency. But can you just describe that a little bit more? The frequency, what does it mean? Frequency of what? What does the 3 mean? Perfect. Okay, so that means right here, there's 3 cars that drove 30 to 39 miles an hour. Is that correct? Right? This then, obviously, you just told me what this means also. This is like the 30 to 39 miles an hour. It's telling me what the car is actually doing. Is that correct? Do I know what these 3 cars are actually doing, though? Not exactly. Does that make sense? Right? I mean, I know a little bit, right? I know they're not driving 100 miles an hour. Is that correct? So I know something. But now the thing is like you got to do something with this stuff. They start saying find the average here. I mean, we have to calculate something. Is that correct? So the average is, we said x bar is equal to the sum from I equals 1 to n of the x values divided by the number of values. Again, I'm just going to try and write this out as we're doing this because we're just starting with this stuff. This means x1 plus x2 plus, and then we just keep going. And then we get to the nth value. And then we divide it by n. And again, all this really means is add up all values. Question? In the sample. And then we're dividing by the sample size. Right? Does that make sense? Average, add them all up, divide by how many there are. Why do I have to write it this way? Because I don't know what you're going to be adding up. Does that make sense? So there's n things here that are being added up, whatever the hell they are, right? And then we're dividing by n. So if there was 20 things here, n would say 20. Is that correct? And then we divide by 20. Is that right? Does that make sense, guys? All right. Now, this is the important part, okay? I was sitting here and saying something about like frequency and value before. Is that right? Does it make any sense to find the average of the frequencies? What would the average of the frequencies be telling us? It would be telling me the average number of cars per class. Who cares? Does that make sense? That's not important. I don't need to know the average number of cars in the classes. Does that make sense what I'm saying? If someone's measuring the speeds here, right? I would be interested in what the average speed of the people were. Is that correct? Does that make sense, guys? You collected all their speeds. Is that right? You're not telling me the average frequency. That doesn't make any sense. You understand what I'm saying? The average frequency is going to be just related to the total number of the sample size. Is that correct? Who cares? I know how many people I sampled. You're going to respond with the average of that? That's just telling me how many classes there are. Does that make sense? Does that make sense? It's useless. Okay. You answer a question like that, you're going to have a problem. Does everyone understand what I'm saying? But we're going to get used to it. Does everyone understand? All right. But this, I'm trying to make sure you identify what the thing is you need to pay attention to. You need to be just able to distinguish whether it's a value or the frequency. Does that make sense? All right. So in this case, they measured a bunch of speeds. I would want to find average speed. I want to always find average value. Does that make sense what I'm saying? We never find average frequency. Got me? It's useless. All right. So but do you understand why? All right. So we gotta add up this garbage. Is that correct? You should immediately be saying what? What's the first thing you start thinking of when you see this? Okay, so what do I plug in? What's my first number? So you should be asking now, what freaking number am I plugging in here, right? These three people, I don't know how fast they're going. Is that correct? Right? So the problem is, as we said before, and this is why I went over this whole thing last time, we said that, you know, we need to come up with some representative value here to start calculating something. Is that correct? So what number are we going to pick for the first class? What'd you say? The midpoint or the class center. Okay. We want to pick the thing in the center. Does that make sense? Because we got to be fair. We don't know how fast these people are going. I can't say they're going all 39. I can't say they're all going 30. Is that correct? So what would that be? Sorry. What's the number? Say again. It's 34.5. Because look, if it's if it's 30 to 40, you should be able to tell me it's going to be 35, right? So it's going to be half less. Does that make sense? Because you have one number less. Subtract one half. So then this is going to be, but don't get me wrong, just do that on your calculator. But I think it should be simple when you say that. Once you get that answer, I think you should be like, yeah, that makes sense, right? All right, what's the next one? Well, class width is 10, so I'm just going to add 10. So 44.5, 54.5, 64, or you just look at it. I think you could do it. And then this is 74.5. Is that correct? All right. So now, what do I do? How? What do I do? So we add up all these and then divide by what? Say again? Add up all those and divide by 5. That's right, right? No, that's completely wrong. No, don't worry. I'm setting you guys up. Trust me. Okay? So like no, I'm trust me. I'm setting you up, and you just you bit that one. I got you. Okay. No, but the thing is no. The reason why I'm doing this is because I know what mistakes you're gonna make. Does that make sense? Okay. So the thing is that this first we need to understand what the frequency, excuse me, frequency versus value, right? And the next thing we need to be able to understand is, well, what values are we even using? Is that correct? And then after that, we have to start saying, well, actually, there's a lot more than 5 things here. Is that correct? Does that make sense what I'm saying? How many things are there? There's 100 is correct. Good. So then this thing here, right? This is like F1, F2, F3, F4, F5. Is that right? If I add up all the frequencies, it's going to give me the sample size. In this case, there's 5 classes. Is that correct? Does that make sense? that make sense? No, but look, 5 classes, 1 to 5. Add up these. Add up F1, F2, F3, F4, F5. Does that make sense? It says do the Fs here, right? This is index thing, kind of tells me which person to point at. Does that make sense? So like if I sat here and I was like, add up all the money these people like which direction I choose, but I would add up money in your wallet, was money in your wallet, money in your wallet, versus I did the money in their wallet was your wallet, but doesn't make any difference. Does that make sense? But I don't know which numbers I'm calling you guys. Does that make sense? Maybe I say first, second, third, fourth, fifth, sixth, seventh. Does that make sense? So I should be adding up then the amount of money from the fifth person to the seventh person. Does that make sense? So this would say I equals 5 to 7. Does that make sense? Where do you get this? I was for this example, sorry. So like but the thing is it's just trying to tell me which things I'm adding up. Does that make sense? So I don't have to write it all out. All right, here, but we add these up here, we get a hundo. Is that correct? All right, but I'm just trying to get you used to the notation. Does that make sense what I'm saying? All right, so we have this. Question? Does anybody have a question so far? All right, so then this now, but again, these two things that we just made a mistake on earlier, everybody says this. Otherwise, I wouldn't have this to go over. Does that understand? Question? Total number of things you sampled. The total number of things you sampled. So if I go here and I say to you, like, I did a survey and I asked 40 people, right? That's my sample size. So in this case, there were a bunch of car speeds collected, and these are the number of cars that were the number of cars with those associated speeds. So then if we add all of these numbers here, it has to be the total number of things that were sampled. Does that make sense? No, that's what I just wrote right here. That's what this is. This is sum all the frequencies. That's exactly what I just wrote. You're 100% correct. All right. But the and I'm gonna write that again in a second, actually. So the no, that's perfect. All right, but you see what it has to be, right? Okay. All right, wonderful. Now, what the hell do I do now? Because this is just the next, it's easy to be a teacher, right? Oh, what do you do? Oh, you can't do it. I'll show you. No. But it's yeah, I'm trying to make you think about it now, because if you think about it now and you struggle with it a little bit, then the next time you look at it, you might actually remember something. Okay. So so you always just try to do it. Okay. So we got to try and figure out what this guy is. Actually, why did I just do that? All right, we got to figure out what this guy is here. So I'm just writing a big fraction here. All right. All right. First, what does the denominator need to be? 100 is correct. All right. So then this is going to be, but I'm going to write it right now as, yeah, whatever. Now I'm going to write it as like F1. Yeah, I'm just going to write 100. Okay. So then we have 100 here. All right. What do we write on the top now? No. But how many times do I write these numbers? Like, what do I do? 3 times is correct. So this needs to be like 34.5 plus 34.5 plus 34.5. Is that correct? Because there's 3 speeds that we're guessing that's the value for. Is that correct? Right? Good. All right. So then you have this. Then we would have, how many times would I have to write 44.5? Yeah, right. But like, you don't do math like this. Is that correct? Right? We write 3 times 34.5. Is that correct? And then we write 16 times 44.5, right? And then we write whatever the rest of this garbage is, 50 times 54.5. And then does everybody understand though why I'm saying this? So then this plus 11 times 74.5. Is that correct? Now look, I'm going to use this notation again now, okay? And I'm going to tell you it's going to start making sense now. Because this is the time when you're going to start seeing something different that you can actually compare and you can see what they're trying to say. Does that make sense? All right, so then this, another way we could write this, just using all these stupid variables and stuff like that. Does that make sense? This is the same thing as saying F1 times X1 plus F2 times X2 plus F3 times X3 plus F4 times X4 plus F5 times X5. Does that make sense? Where this is the frequency of the fifth class times the value associated with the fifth class, right? And this is the frequency of the fourth class times the value associated with the fourth class. Does that make sense? All right, so then we do this. And then we're dividing this by what? F1 plus F2 plus F3 plus F4 plus F5. Does that make sense? Right? Now your book writes this as another formula. All right? I don't really consider this to be another formula. I really consider it to be the same formula. Just the way we have to write it out. Does that make sense? All right. But what the book writes is it says, so in this case, we have to add up the products of the frequency and the value, but for each individual class. Does that make sense? Divide this by the sum of the frequencies. And then sometimes people refer to this as sometimes a weighted average. Because you're sort of like weighting one more than the other one. Does that make sense what I'm saying? Or counting it more times. Does that make sense? Question with this so far? Does that make sense in terms of notation? All right, now the next thing you can do is this stuff here is just n, right? So what I can do is, and this is some other formula they start talking about in another chapter, but they mention it here first. We have to do it a lot though in chapter 5 or something. So then you can do this thing with fractions. So like if you have like a plus b over c, I can rewrite this as a over c plus b over c. Does that make sense? Because if it's like common denominator, you just add the tops. But if it already is the same denominator, you can split it. Does that make sense? So I can break this whole thing up into like 5 different parts. Is that right? And then I'm just going to rewrite things a little bit. All right. So this is like 3 divided by 100. But then there's also a times of 34.5. Is that correct? So 3 divided by 100 times 34.5. Then this is 16 divided by 100 times 44.5, etc. And then this last one is 11 divided by 100 times 74.5. What are these numbers? We didn't call that frequency. Relative frequency. Is that correct? That's the percentage, fraction, whatever. Does that make sense what I'm saying? Right? So those are the relative frequencies. Is that correct? Not coincidental. So then the thing is sometimes people write this like this. This is the true formula usually that people use for weighted average. They start saying, well, we could use these individual weights here. I'm going to call them PI, XI, where this is the relative frequency times the X value plus the relative frequency times the X value. I'm just saying P for percentage. Does that make sense? Does that make sense? And this is referred to as a weighted average. Does everyone understand what I'm saying? Like the one that occurs more often counts more because it gets weighted more with the particular coefficient or whatever. Does that make sense? Number multiplying times it. Does that make sense? Like if you say this thing occurs like 50% and this thing occurs 10% of the time, like 50% times this is going to make this count more. Is that right? Question? All right, let's do this. We didn't get, what's the answer here? That's what you got? Is that what everybody got? I don't remember anymore before. I feel like that's off by a little bit.
56.5.
I can't remember. Don't worry. We do it again right now. Well, you should do it though. I mean, I don't know why I'm not, you can't do it on your calculator. It's gonna be a problem anyway. So you gotta make sure. But there's an easier way to do it on your calculator. Of course, if you don't understand what we did here or why, I don't think where are my buttons? Keep that. There we go. Nice and big. All right. So if we have this here, right? Well, that was stupid. All right. So I want to type this stuff in. Which button do I go to again? Stat. We only touch one button. So stat. Then where do I go? Edit. I mean, it says edit. What else are you gonna do? Does that make sense? This says sort something, clear the list, set up. It's got to go to edit. Again, you better get your calculator. Because right now, it's pretty easy. You do it without a calculator, to be honest. You do it with a regular calculator, all right? But like, I don't know, which chapter? Chapter 5? Chapter 5, you're gonna have a problem. But you can still do a regular calculator, but you won't finish. Takes too long to type it in. Then chapter 6. It's impossible to do these things without the calculator. Because the function is not going to work. Otherwise, you have to know how to use another calculator that's going to do it. Can't do it by hand. Does that make sense? Cannot. All right. So this also, there's another thing that's really bad. The book spends 65 pages explaining to you how to do something. And then it tells you how to use the calculator, and it's like one line. Because it doesn't take much to know how to use the calculator. All right. Like no one ever taught me how to use these things. All right. So it's not, once you get used to it, you can use the other things on it. Does that make sense? All right. Obviously you have to learn in the beginning something, but it doesn't take much to be able to use the calculators. Does that make sense? And that's why the books write it that way. You get what I mean? Because they don't think it takes that much also. Does that make sense? All right. Because there's not much I can say. Oh, you click stat, you click edit, you type in the numbers. You know what I mean? Like there's not much. What am I going to do? Does that make sense? So I show someone how to do that at the beginning, and we keep doing it, obviously. But the book's going to expect you to know how to do it at the beginning, and then it's going to go on to the next 27 different things that it shows you how to do in the calculator. Does that make sense? But it expects you to remember it from before. So it's not going to sit there and keep doing it, okay? And even if you watch videos online, they're going to do the same thing. Because once you get to a certain point, they're like, hey, if you don't know how to do this at this point, you don't know what it means. Does that make sense what I'm saying? So you're not going to be able to understand. That's what they're trying. They're like, go watch the other video first. That's what they're pretty much saying. Does that make sense? So then but my point is that I want you to use the calculator. Just because the book is explaining it first, and the example in my math lab is not telling you to use the calculator, that's because they're trying to make you understand what they're trying to do, right? That doesn't mean you can't use the calculator to do it. You don't have to write it out the same way they do. Does that make sense? So I'm going to be showing you in here how to use the calculator. I'm going to show you how to do it also. But I'm going to show you how to do it once by hand. And then I'm going to keep doing it on the calculator. Does that make sense? All right. You go read the example later, it's going to start doing it by hand again. Does that make sense? You understand? So there's not too many things we're going to talk about with the calculator, to be honest. You have to know how to do them. Have to. Otherwise, you're going to tell me the exam takes too long and all this other stuff. It's not the way I'm expecting you to do it. You're not supposed to be doing it by hand. Does that make sense? All right. All right, so again, let's just practice with the calculator again. Okay, so here, 30, 39, 40, whoops, stupid. 30, 40, 50, then what? 60, 70, those are the lower class limits. I'm gonna go here, push enter at the top because I want to do a list operation. I'm gonna say L1 plus 9. Because if I add 9 to all this crap, I'm gonna get the upper class limits. So then I add 9, boom, it gives me those. Does that make sense? You don't have to do that, of course. You can just type minutes and take that long to type them in, right? But I'm trying to remind you how to use it. Does that make sense? All right, so then this, now, I can't do something with this. The calculator doesn't understand this. Nobody understands this. Does that make sense? I added 9 to, I put L2 here, I pushed enter, and then I added 9 to L1. L1's on the calculator right there. Okay, so then so here, if I need to do this, I need to eventually give the calculator that frequency distribution, xi, fi. Does that make sense? Does that make sense? I don't have the list of x's here, so I'm going to make the list of x's. Does that make sense? So the list of x's is just the average of these two numbers. All right. So that means it's L1 plus L2 divided by 2. Is that correct? And this is the exact same thing you do in Excel. Does everyone understand? All right. Because they're all the same. And this is the same thing you do in programming languages. Okay. So then this. Does everyone understand what I'm saying? I mean, the programming language is a little bit more, you have to learn what they write. It's the same exact bullshit. Okay. So now we have to write the cars. 3, 16, 50, 20, 11. By the way, another thing I think everybody should learn how to do is program. Because if you don't learn how to program effectively, anything that you have to do repetitively, you're going to sit there and do it over and over and over again. I'm going to get the computer to do it for me. Does that make sense? And you're going to sit there like I have this. All right, I'll turn the microphone back on. So then this thing here, this 34.5, whatever this, right? Screw it. I'll even tell them. I don't care. I'll tell them, yeah, I wrote a program. Still gonna pay me. Otherwise, I'm not giving you the program. So I'm never giving you the program. So I mean, it's mine, right? So I'm gonna take my job away. All right. So then this stat. No, but that's how dumb people are. They should have a person working there that should know how to do it, right? Then you don't even need to hire my ass, right? Dumb. All right. So then this thing here. So now we want to calculate something, right? Well, I told you, the calculator does everything for you. Well, it says calc right there. It's probably a thing we should use. All right. So so we go over to calc here. We click one var stats, right? That was the only thing I talked about the other time. That's the only thing you pretty much need to know how to do for the first exam. Does everyone understand? So then you do one var stats here. I push enter. All right. And it starts asking me list and freak list. You recall we talked about this, right? Everybody always remembers freak list. All right. So then where is the list? So the list means list of values. Does that make sense? Where was that? L what? 3. Does that make sense, guys? Where is the freak list? L4. So I go second 4 here for L4. Does everybody see that? And then Buddy's like, Booyaka Shah. Wait. So 56.5. So but my point is that you have to know how to do it both ways. I'm just telling you, I can do it faster, typing it in on a scientific calculator, then you'll do it on this thing. It takes you longer to type that in. Because I'm gonna immediately just sit here and say, it's 34.5 times 0.03. Then it's gonna be 44.5 times 0.16. Then it's 55.5 times 0.5, 64.5 times this. Does that make sense? Like watch. I mean, it takes 2 seconds, honestly, if you know what the formula is. So if you go here and I do this, this is gonna be equals to, right? So I just said 34.5 times 3 plus 44.5 times 16 plus 54.5 times, what was it, 50 plus 64.5 times 20 plus whatever the next one was, 74.5 times 11. But this calculator ain't gonna work unless you type it the right way. And then he says this, I didn't divide by the sample size. You divide that by 100, you get 5.65 or 56.5. Does that make sense? But no, it doesn't take that long, okay? Unless you start pretending, honestly. So but you got to be able to calculate average. Does that make sense? Question? Oh, rats. Elaine. All right, this is why I always find this funny. Everybody always takes all these classes. Nobody knows how to calculate the grade. Nobody even knows what the damn grading distribution means. Kind of a problem. All right, so Elaine gets quiz grades of these things on her final exam. Find the weighted mean if the quiz counts 15% and the exam counts for 55%. All right, all you need to be able to do with these things is be able, if it says find the average, all you got to be able to do is type in the calculator and use one var stats, and you'll be able to get the answer. Does that make sense? How do you type things in the calculator? You need that frequency distribution thing we were talking about. Is that correct? Does that make sense? It's a little confusing sometimes to talk about what the frequency distribution needs to be. All right. But I think it's fairly easy to type it in and use one var stats. Does that make sense? Does anybody have a TI-83? All right. So if you have a TI-84 plus, then everybody's going to do it the same way I do it. If it's TI-83, it works slightly different. So what I would do here is, well, they give me some grades. And they give me some weights. The weights is like how often those things should occur. Is that correct? Frequency. Does that make sense? Plus, if I'm going to find the average of something, I'm obviously going to try and find the average grade. Is that right? The values have to be the grades. Does that make sense? Scores, whatever. So I'm just going to write the scores down because I don't know what the hell else to do. So 84, that's a value. Is that right? Is that right? 78, 89er, 70 duper. Oop, should have badly on the exam. All right, so find the weighted mean of if the quizzes each count for 15% and the final exam counts for 55, right? Well, when I was in school, like it kind of confused me when they started talking about the percentages sometimes, okay? Because I was like, I don't have a number how many times these people have been doing this, right? But if you just thought, like, if you just pretended n was equal to 100, does that make sense? Then how many times did she get an 84? 15. If 15% of the grade is an 84, right? 15% of 100 is 15. Is that correct? So it's like if you started saying it's like these count for 15%, 15%, 15%, and then this thing over here was like 55%. The percentage is kind of confusing. Does that make sense? But why don't we just get rid of them? Why don't we just get rid of them? Why don't we just say, oh, this is 15? It's like that grade counted 15 times. Does that make sense what I'm saying? Then this grade counted 15 times. And then this grade counted 15 times. And then that grade counted 55 times. Does that make sense? Right, then the final counts for more. Is that correct? Counted 55 damn times. Is that right? Does that make sense? Chloe? So then this thing here, so you could write this either way. You could write 0.15, 0.15, 0.15, and then 0.55, or you could write in here actually 15, 15, 15, and 50, 55, and it's gonna give you the same answer. Does that make sense? All right. And if you want to do it on your regular calculator, all you'd have to do then is take this times this plus this times this plus this times this plus this times this, and it's gonna give you the answer. Does that make sense? Because these are actually now the relative frequencies. And I told you the formula is just the sum of the relative frequency times the x value. Is that correct? Is that correct? So all I got to do, the whole reason why people write these stupid tables out is you just multiply these, multiply these, multiply these, multiply these, and add it up. Does that make sense? Question? And if you think about it, this formula is the exact same thing as this formula. Because if I sit here and was to say that this is 15, 15, 15, 55, this stuff here adds up to 1. This stuff here adds up to 100. Does that make sense? So if I do this first thing and use this formula, I would get 0.15 times 84 plus 0.15 times 78 plus 0.15 times 89 plus 0.55 times 72, all divided by the sum of all of this, but that's just 1. Does that make sense? Does that make sense, guys? So this formula always works, okay? This only works if sum of pi equals to 1, right? Question? Money? No idea. What I would do is try and do it both ways. So I want you to try and, oh, actually the answer's on the classworks at the end. All right, but the reason why I'm saying this is I want you to be able to check your work. Okay, so try and do it with writing it like this in the calculator and using 1 var stats, and try and do it this way. Does that make sense? And then if they give you the same answer, it's got to be correct. Also, here, let's just see. Do I have it here? What'd you say? Yeah, they probably just rounded. Now that's the other thing. You don't do this, your whole math lab is going to mark everything wrong. All right. It says round to 1 decimal place. So it's going to mark you wrong. Does that make sense? You were correct though. All right. All right. Any question? All right. This is another good one. GPA. People never know how to calculate GPA. Does anybody know what GPA means? What does that mean? Okay. How does it work? I mean, you just need to know if we got A, B, C, or D, right? Or F, right? They're gonna calculate grade, but you're gonna get an A, B, C, D, or F. You get what I'm saying? Close, but no. What are you gonna say? Anybody? Sorry, Cheval. I think he answered first. He raised me. He was saying first.
Or you would add on the grades that you got with values for each grade, and then you divide.
That's what you just said. What were you gonna say? I'm just saying the only reason why, again, I just set you up again. Okay. The only reason why I'm asking this is I know nobody knows the answer. All right. But I remember when I was in they gave me this stuff in report cards, and I got these things, report cards. I remember I think it was middle school, and they started saying cumulative GPA. I was like, what the hell is this? Right? Now, then it was pretty easy. You're right. You just take the average somehow, and then you just divide by the number of classes. Problem in college is you got credit hours. What the hell does credit hour mean? So really, GPA really means average grade per credit hour taken. Okay. So this actually means total grade points divided by total credit hours. Because the way you say this is like, if you take a 5-credit class, it's like that class occurs more often than a 3-credit class. So the 5-credit class, the grade for the 5-credit class actually counts 5 times. The grade for the 3-credit class counts 3 times. The grade for the 1-credit class counts 1 time. I remember my first semester in college. I remember I got 5 C's and 1 A. I got an A in the 1-credit class. I got C's in all the 3-credit classes because I never went. All right. So and you know, when I was in high school, never got a B. Never got a B in middle school. Nearly got a perfect score on my SATs. Got into a bunch of colleges. Went to University of Florida and decided to do nothing. Like nothing. Well, nothing related to school. Anyway, this don't do that. This thing here. So if we have these grades here, we have to associate some sort of value. What are the values going to be? Values should be pretty straightforward, actually. What values are we going to try to add up? Or find the average of? So what are those? What numbers? 4, 3, 2, 1, and 0. They even write them here for you, right? Does that make sense? Because I mean, we got to find the average of some numbers. Is that right? I can't say average of like A and B or something. Is that correct? So again, try and always make the values and associate a number with it. Does that make sense? All right, frequency. I've kind of already answered this question, but this is a little confusing in this case. What is the frequency associated with these things? Because if we know what the frequencies are, we're done. We just type the stupid shit in the calculator. It's done. Is that right? What are the frequencies? How often do these things occur? What do I write? I don't know. You guys keep doing this. You ask like, try and say a number, because we need to know what you're trying to think, because then we can say if. Wait. So wait, just wait. I'm just asking, what do I write here, right? So what do I write here? 12 is correct. Does that make sense what I'm saying? Okay. But sometimes people are like, I cannot write 3616 here. No, definitely not. Does that make sense? But sorry. Read it. What does the 4 have to do with? What does 4 mean? What does 4 mean? Wait. No, answer my question. What does 4 mean? Read the thing. Tell me what 4 means. 4 means an A is correct, right? So then the thing is this means then how many A's do you have? Is that correct? So you're right. It's a 6, but there's a 6 also for these guys, right? What, are you not going to count that A? You better count my other A. I didn't get that many A's. Okay. So no, but do you understand what I'm saying? All right. So then that's how up. You come on. This A, right? These courses had corresponding number of credit hours. They're even sort of like lined up. C, that class, right? That was my bio class. I had 3 credits. Does that make sense? But then I had this like crazy architecture class, and it was like 6 hours a week. All right. And then I had another one. And then I had this 1 credit lab. Does that make sense? Well, the 6 credit class that I go like all these hours has to count for more. Does that make sense? All right. So that's it. 12, right? So what's the next one here? 3, not 1. Is that correct? There's 3 credits of B's. Is that right? Or wait. No, 1. You were right. I'm sorry. I can't read. All right. 1, 2. 2 is 3 because 3, there's a C with 3 credit, right? And then what about these 2? 0, but we don't even need to write it then. Does that make sense? You could write 0 and that'd be fine also. Does that make sense? Question? Anybody question here? All right, list the range for the given sample data. Does anybody know what range means? So the first thing that we talked about actually is we were just discussing something that was called measures of center. Generally, the measures of center that they start mentioning are mean, median, and mode. I did not go over median here, okay? So I'm going to need you to go over that. Mode is just the number that occurs the most often. Is that correct? You just need to find, sometimes two numbers occur the most often. Does that make sense? I'll do an example with mode quickly. So mode, I don't know. Let's say I had this data set, 3, 3, 4, 4, 5. What's the mode? Three, 3 and 4, okay? 3 and 4 occur the most often. Does that make sense? What if I said it was 3, 3, 4, 4, 5, 5? How do you get that? Which one occurs the most often? You would have to say all of them. Is that correct? When it ends up being all of them, we say there's no mode. Okay? Nothing is most frequent. Does that make sense? Does that make sense? All right, screw it. I'll do median. All right, so then the median's easy. So median, all we have to do is start saying if there's an even number of numbers or if there's an odd number of numbers, okay? Median is referred to as an order statistic. The data set must be ordered. So in other words, you start making them like from least to greatest. Does that make sense? Does that make sense? Indira, question? So then this, so I'm just gonna do n is even. I'm gonna do an example first. So let's say we have, I don't know. Let's say there were 4 numbers. So that means there would be x1, x2, x3, and x4. Does that make sense? The median is the number in the middle, right? Right? What would that be in this case? How would you figure that out? Yep. So the thing is, no, that's right. So the thing is the way I usually think about this is I'm just like, I just start crossing stuff out usually. Does that make sense? So like I cross this one out, 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 and then like whatever's left over, that's the median. And now there's like sort of nothing left over. So then it would have to be like there. Does that make sense? So that's the same thing as the middle of these two numbers. Is that correct? If they're both the same thing, then we just pick that number. But if this is like 70 and that's 75, and this is like 72.5, we say, because it's the number that splits the data set in half. Does that make sense? Does that make sense, guys? All right, so then another example. Let's say n is odd. I don't know, let's say 5. So then if we have x1, x2, x3, x4, and x5, again, it must be ordered first. Does everyone understand what I'm saying? Question? Question? Yeah, there's a different example. I'm telling you how to calculate median just in general. Because well, you need to sit here and start saying when n is even, you sort of get something where you have to take the average of two numbers in the middle. Does that make sense?
Right. Okay.
And then when n is odd, when you do this, we actually end up crossing stuff out, but there actually is one left over. Does that make sense? So then in this case, the answer is just going to be x3. That's the number definitely in the middle. Is that right? Does that make sense? Question? All right. Now, the only reason why I'm bringing this up is because this section's about measures of center. So the problem is that we're always trying to talk about what the center of a distribution is. Center of distribution again is like, so the center of the class was like the representative value from the class, right? Center of distribution, well, we could use the mean, the median, the mode. We can use all these things. Does that make sense? The difference is though that like you can't really like they have different meanings, right? So like the median is the thing when you line them all up, what's in the middle, right? The average has something to do with like sort of like balancing things and where the place where something would like balance. Does that make sense? Right? So they don't mean the same thing, right? The mode is the one that occurs the most often. Is that right? People always tell me, oh, you don't use the mode to do stuff. Well, I do. Like, I don't know, when they have the president, like to figure out who the president is, they count up. Whoever has the most votes, that's who wins, right? That's the mode. Is that correct? Right? When you're a kid and you play sports and you want to go play and it's, you know, you're outside and there's all these kids and you're trying to make teams and stuff like that. Well, that's the first thing that would always happen is people start fighting about making teams, right? I want to be captain. I want to be captain. I want to be captain. Like, you're not being captain. You're not good enough, right? You're good enough. You get to be captain. The other kid, he's good enough. He's the best. He's the other captain because your asses, you ain't being on the same team, right? So then we put those two people on separate teams and then we start picking teams, right? Then the next thing that starts happening is people are always like, you know, who goes first? We know you two are the best. Who goes first? No, I'm the best. No, I'm the best, right? And then the next thing that starts happening is like a fight usually. But but after that we finally resolve it because I want to play the damn game, right? And we would be like, yo, let's vote. Whoever has the most votes, that's the one who's gonna go first, right? So all I'm trying to say is that yeah, you use the mode. Does that make sense? All right. You need to understand the difference of these things and like what they mean, though. Question? Then also you need to be able to find them. All right. Range we haven't done yet. All right. So now they say measures of spread, or sometimes they say variation. The first example is this thing called range. So the range is equal to the maximum minus the minimum. Okay. This tells you sort of how spread out all the data is. Does that make sense? If you were working at like a sales place and you're going in there and you're asking like how much money you're gonna make or whatever, and then I tell you, well, you're gonna make somewhere between $0 and $2,000 a day, right? It's the range of how much I've seen the people make before. Does that make sense? All right. So then we would say the range is 2,000 in that case. Does that make sense? All right. This is a bad estimate though, usually for the amount of spread in a distribution. Spread's telling me like, so like for instance, like if I have a normal distribution like this, and then a normal distribution like this, not everything is normally distributed again, but a lot of things are. So I'm just drawing this picture for now. If I had these two different normal distributions, but like one was like more spread out as compared to the other one. Does that make sense? Does that make sense? This one we say has a smaller standard deviation. This one has we say, larger standard deviation, something to measure the spread. Does that make sense? We're gonna have to talk about that in a second, okay? But range, I need to give you an example why range is like garbage. So because you can use it for stuff, but like if I can do anything else or I need to do anything of like importance or whatever, I'm going to use another statistic because the problem is range is not going to tell me about a lot of things that are going on in the distribution sometimes. All right. For instance, if I sit there and I start saying there's like a lot of numbers, let's say that are like grouped around here, more numbers, more numbers, more numbers, that guy also. And then there's like this guy over here. And then there's like Richie Rich over here. Does that make sense? All right. So somebody who's like super duper poor, the rest of us, and Richie Rich. Does that make sense? This is not the true way that the true monetary distribution looks in these places, in anywhere practically. I'm just giving you an example. The true monetary distribution actually looks more like this. Let's see. Screw it. That's a good video. Let's just go look real quick. This is old. Okay. It's gotten much worse. Yeah. They're not even. They don't care. They just keep getting elected again. They're all garbage. But you want to help people, I can tell you how to help people. They're not trying to help you. Got to make that money. All right. So this is what people think is the way that the wealth distribution works. Okay. That these rich people have about that much money, poor people have about that much money, middle class have about this much money. Okay. Or excuse me, this is the way people think it should work. I'm sorry. Okay. This was before also. This is what Americans think that the way everything is. Does that make sense? Not so great, but not so bad. That was what Americans think is the ideal way. So which is kind of really screwed up when you think about it, because it's like, okay, they say there shouldn't be that many poor people, but all of a sudden you're telling me there should be a lot though. Right? Like, why is that ideal? Why is that? I don't understand how that's ideal. Anyway, but whatever. All right. That's what some dumbasses said. Okay, so then this now you have by the way, it's from Harvard. This what American think the distribution is, okay? All right. Interesting. Then we get to what actually starts going on though. This is the actual wealth distribution. And like this guy over here, he's kind of interesting. So like actually like nobody has any money, right? And then they start doing this dude. One guy, upper 1% of the population. And again, this has gotten worse because this was like 2006 or something. But or like I don't remember, something like that. But my point is that understanding distributions is really how you understand what goes on with these things. Is that right? And I don't think you thought that this is really the way it works. Okay, that was that dramatic. And I'm telling you it's even worse. Okay. But because Elon Musk has crazy money. Is that correct? Right. All right. So the thing is if you start talking about the wealth distribution really sort of looks like this. This is like the frequency distribution associated with the wealth of people in the United States of America. Let's say. Most of them are grouped down here. Does that make sense? All right. So my brother, he unfortunately passed away, was a drug addict. Okay. And he died from a drug overdose. And the dude had not a dime to his name. Not only did he not have a dime to his name, robbed everybody I knew, all this stuff. My mom, me, all kinds of people, right? So didn't have anything. So this is my brother. All right. And then there's Elon over here. Well, I can't wait to fight that cage match because he's gonna get his ass kicked, actually. But then this, right? There's Elon over here. Okay. Dude has how much money? I don't know. Whatever. Something in the hundred billions of dollars. Does that make sense? Okay. So buku money over here, right? Hundreds of billions of dollars. All right. Now, if you wanted to talk about the actual spread of this distribution, I would say most of the stuff is actually occurring, let's say over, I don't know, let's say about there. Does that make sense? Is that correct? If I start doing the range here, it's going to calculate this, the maximum minus the minimum. Well, I don't really care about Elon and the poorest or lowest possible person, unless there's a lot of the poor people. But I don't really care about Elon, to be honest, to talk about what goes on in the overall United States of America. His result is so infrequent. It doesn't represent the overall thing. Does that make sense? So using this distance here versus this distance makes a dramatic difference. Does that make sense? Does that make sense? All right. So range sometimes Elon is what we refer to as a outlier. It's a number that's not representative of the regular or most the values that are typically occurring in the distribution. Does that make sense? All right. So range is sometimes going to be dramatically affected by these outliers, because that's something I really shouldn't be including. Does that make sense? So we need another way to do this. So they say this thing, standard deviation. You know what standard deviation is? You know what this is? They teach us in algebra in the middle school. I mean, excuse me, high school. Standard deviation. Standard deviation is sort of like the average the square root, sorry, of the average squared deviation. The formula is this is why I had to keep writing all this stuff with this other format, because there's no other way to write this formula. This is referred to as the sample standard deviation. Then there's also the population standard deviation. And this guy is called the population standard deviation. This symbol is called sigma again. This is the lowercase sigma. The other one was the uppercase sigma, all right? This formula is easy. It looks bad, but I'm gonna show you. It's gonna make sense. It's gonna be easy. Then we're never gonna do it again. We're always gonna do it in the calculator, okay? But you gotta understand what the damn thing means. You understand what I'm saying? All right. But I'm intentionally making this example so it's going to be simple to understand, okay? You are going to guess the answer before we do it. I promise. Does everybody understand what I'm saying? All right. I know it looks like Greek, but wait, it is Greek. Literally. All right. So then no, but for real, this is a confusing formula. Okay. And like I think most of the time you start putting this up and some like this is where people start running away. All right. But the thing is it's gonna be a joke in a second. All right. Because I'm gonna give you an example where the numbers are gonna make sense. All right. And I'm telling you, most of the time, the numbers aren't going to make that much sense to people because you have to take the square root of something at the end and you're going to get some crazy decimal. Does that make sense? So people get confused what that means. All right. But we're not going to get a decimal with this because I'm making up numbers that are going to work nice. All right. So let's say we had set one, and set one was the numbers 99, 100, and 101. Okay. And then let's say set two is the numbers 0, 50, and no, let's say 0, 10, and 20. All right, so before we start now, we're not guessing yet, okay? Which one is more spread out? Or which one has a higher spread? Does that make sense? What would you pick? Set one or set two? Set two is correct. Does that make sense? Which ones are the data points more spread out? Is that correct? All right. Set 2 is correct. Now we're gonna guess. How spread out is the first one? How spread out is the second one? How spread out are the numbers in the first one? How spread out are the numbers in the second one? What would you pick? What would you pick for the first one? What would you pick for the second one? 1 in 10. Go ahead, you got the answer. You're right. It should make sense in this exam. Is that correct? All right, but now we have to calculate it. Okay. So I write out this little table to help organize myself when I'm doing this stupid thing. We're only going to calculate the sample standard deviation in this case for this one, but effectively, like this bottom part, n-1 here, like that's not hard. Does that make sense? Doing square root, that's not hard. I'm just doing it on my calculator. Is that right? So it's this garbage. That's my problem. Whatever goes there. Is that right? This entire table is only to figure out whatever the hell that stupid thing means. Does that make sense? But also I'm going to explain what it means as we're doing it. All right. So first, I'm going to draw all these numbers on a number line. What's the average of these values here? $100. So X bar in this case is 100. Is that correct? We define a deviation from the mean to be equal to Xi minus X bar. Does that make sense? Deviation from the mean. How far apart are you? Does that make sense? So I'm just going to say this thing is deviated. It's 1 less. Is that correct? This one is actually has no deviation. It's equal to the mean. Is that right? And then this one is deviated 1 more. Does that make sense? All right. Versus this here. Again, X bar in this case. What's X bar for the second one? 10. Similar types of deviations, but these are larger in magnitude or size. Does that make sense? Right? So, all right, let's write out this bullshit. So I write out the numbers. This one is X1, X2, X3. Does that make sense? What this thing says is find the deviation for each number, right? Square them, add all that crap up. Does that make sense? Does that make sense? Find the deviation, subtract, square it. No, deviation is when you already subtract. Right here is, so what's the deviation for 99? -1. What's the deviation for 101? 1. So deviation for 99 is -1. Square it. Just let's write it out. You'll see when I write it out, it's easy. All right, so Xi. First write out all the, but before we write this out, what I meant to say was that this here, we need to know what the mean is first. Is that correct? I mean, for sure it says like something minus the mean. Is that right? I gotta know what the mean is. So this 99, 100, 101, I just write them down, right? Then we're gonna just keep writing totals over here. Does that make sense? So this is going to be the total of the x's. What's the total of the x's from I equals 1 to 3? 300. All right, everybody should be doing this. I don't know why people are looking at this like it's impossible. So this thing here, like add up these numbers. I just said we need a total. Is that correct? I'm just keep writing notation so you get used to it. Does that make sense? Just the way they're going to write the formula, you better understand notation, right? I'm telling you, there's no other way to write it. Otherwise, I would. But this, so we write this here. We divide this by what to determine the mean? Three. If we divide this by 3, now this gives us the average, 100, right? All right, next we should calculate what the deviation is for each of the values. Because there's all these deviations here. Is that right? What's the deviation for the first value? How do you get that? You do 99 minus, we just figured out X bar was 100, so we get -1. Is that right? Then what's the next one? 0. Next one? 1. Is that correct? What happens when I add up all of the deviations? You get 0. That's not good if we were going to use that to measure the spread, because the spread here is not 0. Does that make sense? But that stupid thing is always 0. I can write out a proof if we have to understand it, but trust me, it's always 0. If you add up the amount that everything is away from the mean, some's going to be bigger, some's going to be smaller, they're going to cancel out. Does that make sense? Does that make sense? So that's always going to be 0. So that's a bit of an issue. We can't get the spread as 0 all the time. Is that right? Plus, these are definitely not spread out by 0. So then it says here to square it. Is that right? So then I'm going to do that now, I guess, because we got to figure out this stupid formula. So we got to square it for each of the numbers. Does that make sense? Does that make sense? So what's the first one? -1 squared is 1. Is that right? What's the next one? And the next one? 1. So then again, what do we do down here again? Oh, we write down what the sum of all this stuff is in the column, right? But now it means it's the sum of all of this. Is that right? Does that make sense, guys? What is this equal to? 2. Is that correct? So then that means the sample standard deviation is equal to the square root of the sum from I equals 1 to 3 of xi minus x bar. X bar in this case we said was 100, right? All divided by n minus 1. Okay. So wait a second. This hard part, we just did it. It's 2. Duper. Is that right? What do I write in the denominator? What's n in this case? 3 is correct. There's 3 numbers here, right? This is a sample size of 3. Is that correct? So we get 3 minus 1. Is that right? So now this is going to be what? Root 2 over 2. That cancels. You get 1. Is that right? Square root of 1 is 1. Yeah, that's what you said the answer was at the beginning. Does that make sense? They're 1 spread out. Is that right? Does that make sense? All right, I'm just going to do the second one a little bit faster, okay? And then we're going to do it on the calculator. Does that make sense? All right, but I already taught you how to do it on the calculator. It's one of our stats again. We just have to scroll down a little bit on that list, okay? So this now, if I do it for this one, I'm not going to write it out as much because we really don't need to do these 2 separate steps. I'm just trying to explain to you here what a deviation is and why I have to square things. Does that make sense? Does that make sense? All right, so then this, I'm going to write down the numbers again. Well, I need the average, so I guess add them up. So x bar equals to what? Add these guys. Sometimes the books don't, like your book, I think, doesn't write the I here. It just writes that. That's actually bad notation. They shouldn't do that. So this is I equals 1 to 3 divided by 3. What's the sum in this case? 30. 0 plus 10 plus 20, right? 30. Is that correct? So then we get 10 for the average. Is that right? So now we got to do, I mean, yeah, it's xi minus x bar, but I mean, I could write up here also just xi minus 10 squared. We know it's 10. Is that right? Right. Like I just, but that's what I was saying at the beginning. have to be able to know what the average is to do this. How do you find the deviation from the average if I don't know what the average, right? Does that make sense? All right. And you understand the word deviate, right? All right, change, sort of like what the change is. Does that make sense? All right, so then this xi minus x bar squared, right? All right, can you tell me what I need to write here? What goes inside the parentheses? 0 minus, what'd you say? Tn. Good, right? So that's negative 10 squared. What do we get? Hundo. Is that correct? Next one's going to be what? 0 is correct because it's 10 minus 10 now. Does that make sense? You get what I mean? You got to do it for all the points, right? Everything in the distribution. How far is it away from the center, right? So they're finding like the average. So this is why I put average in quotation. Because this says n minus 1, not n. Does that make sense? All right. So we're kind of like the average. If it was the average, though, we would be dividing by n. Does that make sense? All right. But we're not dividing by n in this case because the problem is I don't have the entire distribution. When we're dealing with a sample, we just divide by n minus 1 because we might be missing something. And then it sort of overestimates what the overall spread is. Okay, because you divide by a smaller number. Does that make sense what I'm saying? So then but you just need to know the formula. All right, that's all. And on top of that, the calculator is going to do it all for you. All right. But this thing, 0 minus 10 squared is 100. Does that make sense? What's the next one here? Sorry, you said 0, right? Does everybody see that? What's the one after that? 100 is correct. This is 20 minus 10 squared. You get 100. So then what if I wrote this? Sum xi minus x bar squared from I equals 1 to 3. What would that equal to in this case? What did you say? 200 is correct. Then this is, now I'm just writing out the formula because the more I write out the formula, the more you're going to tell me you can understand what it means. So then we have this, right? Then this. So we just did the top part, right? So what do I write here? 200. What's the denominator? 2 minus 1. Or excuse me, 3 minus 1. I'm sorry. 2 is correct. Does that make sense? Right? Now this here, what do we get? 100. So this is square root of 100, which is tan. Yeah, these things are like 10 spread out. Does that make sense? Question? All right, now I'm gonna do a calculator. And then this is where you should start telling me you appreciate the calculator, okay? Because there's a reason why we're doing this. There's some teachers who sit here and tell you have to write everything out by hand. They're psychotic. Or they haven't done statistics before. Because anytime I do statistics anywhere, I am not writing this shit out by hand. I'm gonna get it wrong. Okay? And then what was the point? Does that make sense? Right? I could show you some stuff where I do statistics. You have no idea how many numbers there are. Does everyone understand what I'm saying? This is to understand. Okay? We get 10,000 numbers? No, we're not doing this. What is it? How long is it going to take? Does that make sense? And then how many times are you going to screw up? All right. Back to La Calculadora, right? All right. So now we go to where? Oh, wait, I only told you one button. Stat, right? Stat. All right. I'm going to go in here and clear out some lists because I got all this crap in here, I think. Actually, you know what? I'm just going to reset my calculator because I'm just going to start over. I can recall how to do that. I haven't watched that video in a long time. Where'd it go? It just shut off. This is what happens when you use bootleg programs. I do think I posted this online though, in case anybody wants it. All right, should be fine now. Okay, so, oh no, I just started over completely. Damn it. But you guys can always go whenever you want also. So the, you don't have to wait if you need to go. All right, so then stat, this thing, edit, right? So we have this, okay? So I'm gonna start typing these things in here. I'm just typing in the same numbers of whatever we just calculated. So that was what, 99, 100, and 101? 99, 100, 101. And then the other one was, what was it? 0, it was like 10, 20, and 0 or something, right? Okay, so these things, is that correct? So now I go to stat, calc, one var stats. Does everybody see that? One var stats. Now, first I'm going to deal with the first list. It's already done. Is that correct? This says X bar. This says sum of the X's. This says sum of the squared X's. This says the sample standard deviation. This says the population standard deviation. It just gave us the one that we got before. Does that make sense? This says the sample size. Is that right? This says the minimum value. This says the maximum value. This says the what? What's this one? Median. So the only ones we haven't done yet are these quartiles here. But this is the 25th percentile, and this is the 75th percentile. Does that make sense? All right. Percentile just means the percentage of stuff less than it. Does that make sense? So if you're in the 88th percentile, that means you did better than 88% of the people that took the test. Does that make sense? All right. Now, I'm just going to do it one more time just to show you what the number is here again. Again, you need to know the difference between sample and population. Does everybody see that? You also need to know the difference between variance and standard deviation. If I say the sample standard deviation, they're going to say S. If I say the sample variance, that's S squared, okay? It turns out in other parts of statistics that the variance matters more, so they name it, all right? All you have to do is remember the name. I'm going to ask you it on the test. All you have to do is square it. Does that make sense? All right. If you do the population, then we call this one sigma. This is the Greek letter. Always with the population stuff, it's always the Greek thing. Does that make sense? Then the variance for that, we write sigma squared. I'm just reminding you that you need to square this. Does that make sense? Does that make sense? And then this is this, and this is this. Oh, it was L2, right? One var stats. Change this to L2. Never see that? And he says the sample standard deviation is 10. Okay? All right. That is all. Thank you. I always take attention to the beginning. I always take it at the beginning. I don't take it again. It doesn't really count for anything. The only time attendance matters is for the never attended period, right? So if I got your attendance at all and you signed up for my math lab, then you're in. All right? Have a good evening. What's up? Yes, sir.